Everyone, we have the pleasure of having Gauti Eggertsson, who is a macroeconomist and a professor of economics at Brown University. He received his PhD in economics from Princeton University in 2004, after having completed his BS in economics from the University of Ireland. And he has worked at research departments at the International Monetary Fund and the Federal Reserve Bank of New York. And since graduation, he has also been a visiting faculty at Princeton, Yale, and Columbia, where he taught international finance and macroeconomics at both the graduate and undergraduate level. Professor Eggertsson has published in a variety of professional journals, such as the American Economic Review and the Quarterly Journal of Economics. And the main focus of his work is in the analysis of monetary and fiscal policy over the business cycle, both from a modern and a historical perspective. So it is a great pleasure to have you here today, and the floor is yours.
Thank you, and please feel free to jump in with questions. This is my first web seminar, so this is a little bit new, uncharted territory for myself. So what I'm going to talk about today is I'm going to talk about this idea of secular stagnation. Now, a few years ago, I would say maybe 4 years ago, I didn't even know what the word actually meant or the concept. So let me explain to you where it's from. And I guess I can show it to you with a picture. Let me see if I can work the graphs here. So this picture here shows you industrial production in the United States during the Great Depression. So you have this dramatic collapse in output from 29 to 33, and then you have a rapid recovery from 33 to 37. 37, there's a second phase of the Great Depression and a steep or a sharp recession in 1938. And precisely there, if you look at the bottom of this figure where things look particularly dire, a professor at Harvard University, Alvin Hansen, gave his the annual speech at the American Economic Association that predicted or suggested that perhaps the condition people were facing at the time, zero interest rate, high unemployment, output growth slow, were here to come for the long run. And this idea, and he would trace that to sort of excess of savings, sort of a very old Keynesian idea, excess of savings and lack of investment opportunities, tracing it to, among other things, to things such as demographic change, the slowdown in birth rate people saw during the Great Depression. So, we saw a recovery starting in 38, and then came World War II. And this idea of secular stagnation sort of faded into the background. However, after the World War II, there was, in fact, in the U.S., great concern that U.S. would tumble back into Great Depression for reasons including, or especially because of the secular stagnation hypothesis. So in the 40s, early 50s, this was still a very hot topic. Not so much when I went to grad school or undergraduate, so I just first heard about it in 2014, or 2013 actually. And what was the reason for hearing about it? Well, this was an idea sort of resurrected by in a speech in 2013 by Larry Summers. And so he suggested we should, in 2013, we still had nominal interest rate at 0 in the U.S. Things were not looking particularly good, and people were concerned, when is this going to end? I mean, are things finally going to recover? And I suppose what caught my attention, my particular attention, and my co-authors, was the way in which Larry suggested to formalize this idea. He suggested that maybe we should think of this as a persistent or even permanent decline in the natural rate of interest. So what do I mean by the natural rate of interest? I mean the real interest rate the central bank would need to achieve for full employment. The implication then being a chronically binding zero low bound. So for somebody like me, sort of a modeling geek, so I was at the New York, well actually I just moved to Brown, but these are issues that I've been thinking a lot about when I was at the New York Fed. This suggestion was actually, of this thought experiment, was actually not as simple as one might first think, because the model that I had been working with and several others, for example, the New York Fed model at the time, and I'm sure a lot of the models in that central banks in Latin America were using, in that model, the steady state real interest rate was actually fixed, given basically by the inverse of the discount factor of a representative agent. So the thought experiment of thinking about a permanently binding, a permanently negative natural rate of interest was actually not that easy to contemplate. Even in models of heterogeneity, like I had a paper with Paul Krugman in 2012, where we had borrowers and savers and contemplated debt deleveraging shock, there too, the prediction of the model was a temporary reduction in the natural rate of interest in response to debt deleveraging shock, and then things would return back to normal, where normal would be defined by a positive real interest rate defined by the discount factor of the representative saver. So in embarking on this project, we sort of had to do a bit of an open heart search of the standard New Keynesian model that I was used to use at the time, which had a representative saver or a representative agent. So that was sort of on the demand side, but actually on the supply side, there was some major adjustment that we needed to do as well, because we wanted to contemplate a permanent slump, and that's going to be what I'm going to walk through with you here today. I'm first going to walk through a very simple example we constructed where you can think about a permanent slump characterized by a permanent negative real interest rate. And then I'm going to try put that very simple example into a larger scale model, 56 generation overlapping generation model, to see if it's sort of quantitatively reasonable. So before just diving in, I'm on the next on the slide after the next, I'm going to give you a preview of the result, and then I'm going to dive straight into the model. I just wanted, before getting there, show you one more picture with data, and the point here is simply, well, I suppose we're now seeing some recovery in interest rate in the U.S., and the question is whether this is something we do not need to concern ourselves with anymore. I suppose I just wanted to point out to you, this is a picture of a long-term, this is a picture of interest rate in the United States over the past, close to 30 years, and what we see there is a persistent decline in 10-year treasuries, right? You see here, very close to modern day, there has been a slight improvement. That's the so-called Trump boom, but you see how small it is when compared to this time period. And this is a period, just to remind you, this is nominal yields. This is a period with stable inflation, so you know it's not an unreasonable measure of real rate. And the thing I would just want to highlight here is that in the recession, so the gray bars denote the NBER dated recessions. So we see here in the first recession in the 91 on this chart, the Fed, which is the blue line, cut interest rate from their peak from 10 to 3, so accumulated cut of 7%, okay, to get things moving again. In the recession following the dot-com bust, after 2001, the Fed cut the rates from 6.5 to 1, where it was in 2004, or accumulated cut of 5.5. And at 1, in fact, as some of you may recall, there was a notion at the Fed that it would be not advisable to go further. So the Fed started using forward guidance as a supplement because it didn't want to go below 1 threshold. They then crossed, of course, a few years later. But the point is that there, it took 5.5% cut get things going. And now here in the latest recession, we see a reduction of the Fed's fund rate from 5.25 to 0, or accumulated 5.25% cut, and yet we did not really see a robust recovery of inflation and output. All this is just to say that chances are we're going to see a recession at some point in the next few years, and I suggest to you that we are probably not going to have reached the peaks that we reached before with the Fed funds rate before that recession comes, suggesting that the zero bound may be a problem going forward in the next couple of recessions, and even longer than that, suggesting that this problem is here to stay and one that we need urgently to understand better. So that's the objective here of the talk today, is try to understand the consequences of the brown line here, the long-run interest rate or the neutral rate, permanently declining to such an extent that the zero bound becomes an issue repeatedly, and in the extreme is always an issue. So let me just give you a preview of the results. Or preview of the question and the approach and the result. So the first question is if we can formalize this idea, and the answer to that is going to be yes, and I'm going to show you exactly how we propose to do that, and show how a permanent slump can be a permanent theoretical possibility, or more generally, we will have repeated episodes of these CLB crises of the kind we saw in 2008. And then we're going to ask, I'm going to show you this in a very simple analytic model, but then I'm going to try to go beyond that and ask, is this like a quantitatively reasonable possibility? And to address that issue, I'm going to work with a medium scale DSG model, 55 generation capital, and think about demographics and so on, and productivity. So the first is just going to be an illustrative model, and then we're going to go to the quantitative side. And we're going to see that I think at least it's hard for me to, let me put it this way, it's easy to construct a quantitative model, in which case this is going to be a problem for the unseeable future, mostly due to things like demographic and slowdown in productivity. I'll be specific about what factors are the most important when we get there. Okay, so the start is going to be just a simple 3-generation OLG model. The natural rate can there be permanently negative. And I'm going to add to that, that's sort of going to be on the demand side. And on the supply side, I'm going to add asymmetric nominal rigidities via downward wage rigidity that allow us to account for a persistent or even permanent recession. And then, as I said, we'll go to a quantitative model. So feel free to jump in with any questions. I'm going to give you on the next slide a little bit of an overview, and then we'll get to work on the model. So if I preview the results, I sometimes like to think about the model of the zero bound as 3 generations. The first generation, we would assume the shocks would just be sort of exogenous preference shock. Second generation, debt deleveraging shock. And I see this class of models as sort of a 3rd generation, where we go sort of deeper into what is triggering the natural rate of interest and possibly leading to very low frequency movements. And that's what we're going to do here. And the things I'm going to emphasize that can permanently suppress the natural rate of interest are going to be productivity, demographics, so either slowdown in birth rate or a reduction in mortality rate. Increase in income inequality is going to be another factor. That deleveraging shock is going to make a presence, just like in the 2nd generation models. And then finally, a fall in the relative price of investment. I'll try to give you intuition for and even quantify the extent to which each of these have played a role. So what we're going to see here then is a permanently binding zero lower bound. It's going to be sort of an extreme example where we have deterministic model in which it's binding forever. The point, of course, then being that you can imagine the economy fluctuating around such a steady state, so that the zero lower bound is binding in a chronic way. And this is something we couldn't really contemplate in the existing first or second generation CLB models, because literally they would blow up if the persistence of the shock was too big. And the key here is to model the demand side, moving away from a representative agent framework. So what do we get out of this that is new, apart from a permanent recession? Well, one of the things that we're going to see, and this formalizes a criticism actually Paul Krugman levied against the Bank of Japan when they tried to raise their inflation target. He called it the law of the excluded middle, and his point was, well, if the natural rate of interest is negative enough, then you better announce high enough inflation target, because if it's below the negative of the natural rate of interest, it's going to have little or no effect. And here we're going to see it has no effect at all. I'm going to call it the law of the excluded middle. So in other words, there's going to be a multiple of equilibria, in that there's going to be one equilibria consistent with high inflation and another that is secular stagnation one. But the high inflation better have high enough inflation to accommodate the shock. We're going to see more or different role for fiscal policy than in the sort of more conventional framework. And this comes about mostly due to the OLG structure. And so it's going to matter a lot how, if you increase debt, who pays it, who's going to pay it, if it's a permanent or temporary increase in debt, and so on. So let me just get to the model or show you the structure here. So the outline here of the presentation is going to be, basically it's going to have three parts. First, I'm going to show you a very simple model. I'm going to try to boil it down to a bare essential, and I'm going to sort of build it piece by piece. I'm going to start with the most simple example I can think of, which is basically an endowment economy, where output is just dropping from the sky. You have three generations, and they're deciding whether to consume or save. And the point there is just going to be to show that, in contrast to the representative agent model, it's going to be pretty natural to think about permanently negative real interest rates, which then translates into possibly a recession when you have endogenous production. I then talk about monetary fiscal policy, and then I move to quantitative model. Now, I just saw popping up a question here that I'm going to address before I dive straight into the model. And the question is, how do international factors, as a larger supply of loanable fund to the U.S. global saving glut, are factored into your framework? That's a great question, and it's a question that, in fact, I tried to address in a paper that came after the one I gave today, which is joined with Sanjay Singh, Neil Merthroda, and Larry Summers, and there we explicitly tried to consider how the fact that you have many open economies, how these saving investment imbalances propagate across countries. And I'm going to talk about it a little bit in the conclusion, but probably not get too much into it. But there are some very interesting features on it. In particular, you are going to see there that running current account surpluses is going to, usually that will just transmit to your trading partner lower interest rate. But in this environment, it's actually going to propagate a recession. So you could even say that something like that formalizes the Trumponomics notion of the evils of trade imbalances, although he has been talking about it since the 80s, so I don't think it has anything to do with the mechanism we're talking about here. Okay, but let me get into the model and talk about what we get. And again, I will come back to the international factors at the end of the talk. So think about here, I'm going to give you a very simple model. So time is discrete. There's only a single consumption good. Output is just, dropping from the sky. There are three types of agents. They're young, they're middle-aged, and they're old. And we're going to think about the middle-aged people that's receiving the endowment. So what do the young people do? Well, they need to borrow from the middle-aged in order to finance their own consumption. What do the middle-aged do? Well, they lend to the young. No, they lend money to the old to save for their own retirement when they're old. Okay? The form of the asset market is going to be, we're going to assume there's only one period risk-free bonds, BI, and then we're going to impose the constraint that you cannot borrow more than corresponds to some D that we're just going to take as given. And one of the thought experiments we're going to do that is sort of similar to what I did in my paper with Krugman in 2012 is to explore the consequence of a decline in that D. Okay, so how is an equilibrium going to look like in this kind of model? So let me give you more specifics. So people here live in these simple log utility function. They get utility when they're young, middle-aged, and old. But then if you look at their budget constraints, when they're young, the only way in which they can consume is to borrow against their future income. Then when they're middle-aged, they get income. They have to repay what they borrowed when they're young, and then they will accumulate some. Will accumulate some assets for retirement. So that's a negative BN. Then when they're old, they might receive some income, and then they will spend whatever assets they accumulated through lending to the young and middle age. So that's the BT plus 1N. Finally, there's a borrowing constraint, which is given in the bottom equation there, that the young cannot borrow more than corresponds to DT, which is we take fixed as given. So in other words, and we have this inclusive of interest rate. So, and this is going to be binding from the young, so they cannot borrow more than corresponds to DT, and that it's inclusive of the interest rate they have to pay then once they become middle-aged. Okay, so very basic structure, same as Samuelson 56 basically, and this is the solving it is easy because we're going to look at an equilibrium in which the youngest generation is going to be constrained. It's going to be borrow as much as it can up to this debt limit. So we're just going to assume this D is small enough. So the debt limit I showed you in the last slide, in the bottom equation here, is going to be binding. So they're going to be at the corner. The middle generation is going to be solving a standard consumption Euler equation. So they have an interior solution. So the way in which interest rate is going to be determined here is via the consumption saving decisions of the middle age. So they equate their marginal utility of consumption to the marginal utility of consumption when they're old, and then the interest rate is the thing that makes these things balance, and the discount rate beta. Okay, finally the spending of the old is then just given by they will spend whatever income they get when they're old plus their savings. So we don't have any bequest motive here, but we will have that in the quantitative model when we start sort of trying to capture the data a bit. So how would an equilibrium look like in a world like this? Well, it's an endowment economy, so output is just a given. The thing that is being determined endogenously here is the real interest rate that clears the market, the loan and the lending and savings market. And what does that market look like? Well, that's just going to be the aggregate savings in this economy is just going to be given by the number. Well, let's talk first about the borrowing. The aggregate borrowing in this economy is just going to be given by the number of young people, which is NT, times the amount of borrowing they get, which is BTY. And this has to be equal to the saving in this economy, because remember, there's no capital here. It's an endowment economy. We will add capital later, but we're going to get a bunch of insights from the simple endowment economy. So the aggregate savings is just going to be the asset holdings of the middle-aged, right? And the number of middle-aged is going to be NT minus 1. So the number of people at time t that are born in time t is NT, and the number of people born in the previous period is NT minus 1. If I define the 1 plus GT as the ratio of NT over NT minus 1, I have the growth rate of the population at time t. So what we see here in asset market equilibrium then is simply equating loan demand to loan supply, showed at the bottom half of this slide. And what you can see here, if we define the loan demand and supply in this particular way, and in the second equation I've assumed perfect foresight for simplicity, we see that the loan demand is going to be a function of the borrowing rate, of the debt limit. It is also going to be a function of the growth rate or of the number of people being born at time t. So the younger the population, the more loan demand you're going to have, because the people in this economy that want to borrow are mostly those that are young. If you think of borrowing against, your student loan, borrowing against your future income, your first purchase of a house, and so on. So the younger the population is, the higher is the demand for loans. Meanwhile, on the supply side, you see that the loan supply is going to be determined by the relative income you receive in middle age versus old age. Okay, so already here you can see you have a very basic insight, namely that the expression here for the interest rate, the real interest rate, in the representative agent model, this would be in steady state 1 over beta. Here, however, there's no particular reason to expect this to be 1 over beta. It's given by this more generic formula. And so in particular, you're going to have, the collateral constraint D, or, the debt limits, can have long and persistent effect on the natural rate of interest. I don't have here, I haven't explicitly introduced productivity in the notation here. It's in the paper, but lower productivity is also going to reduce the real interest rate. Lower rate of population growth, and this was the mechanism Hansen emphasized quite a bit, is also going to reduce the real interest rate simply because it reduces the demand for loans. There are fewer younger relative to middle age. Higher middle age income relative to the old is also going to, the more hump-shaped the income life cycle profile is, that's also going to put downward pressure on interest rate, and so on. Let me just emphasize, so the bottom line here is that simply that there's no particular reason to expect the steady state interest rate to be permanently in its steady state to be positive. It can easily be negative in this simple framework, and this result survives even if you introduce additional factors like capital and production and so on. And the key thing here is just to abandon the representative agent framework and make the empirically relevant observation that people die and borrow and save over their lifetime. So this here just shows you one thought experiment out of these several that was shifting the loan supply and loan demand, and I picked here just one that was sort of close to my heart because it's from my paper with Krugman from 2012, where we showed the effect of a debt deleveraging model where you had a representative saver and borrower, and then you see, I have a question here that I'm going to respond to once I've done with the graph. My apologies. Here you see reduction. So here you have a debt leveraging shock, your reduction in loan demand, and in the Eggertsson-Krugman model, so you would then go from A to B, you would have just a temporary reduction in the real interest rate, but then in the next period you would go to D. Why? Because the representative saver was getting less income because there was less lending going on, so the supply of savings was shifting back. Here something else happened which is sort of interesting. So the young take on less debt, but what does that mean? They switched from being borrowers to becoming savers in middle age. So the fact that they took on less debt means that they will have less debt to repay at that point. So that's actually going to shift out loan supply further, and you're going to go to C. In other words, there's not going to be a debt deleveraging cycle where once you deleverage, you're going to just go have a temporary reduction in interest rate and then go back to normal once the debt deleveraging cycle has run its course. Here instead there is this long persistent effect of a permanent decline in D. So in other words, the natural rate of interest inherits the persistence of the debt deleveraging shock. So a question here that I've already had, which I see here on the screen, how could increase in life expectancy be captured in the model? So the short answer is here: I have young, middle-aged, old, and people, and the old people die with certainty is that I don't capture it right here. But in the quantitative model, we are in fact going to have 56. We're going to have people live till the age of 80, and they have survival probabilities between each and every year of life, and that's then naturally going to allow you to think about what's the effect of increase in life expectancy, because that's basically going to give the middle-aged more incentive to save. Okay, it's not captured in the simple model. You can kind of see the mechanism already there. That basically you think just with a lower income when old, that's going to make you want to save more. But this is going to become perhaps a little bit more clear in the quantitative model. But in this simple model, I guess what we can see is the effect of reduction in the population growth. Namely, there are fewer young people relative to the middle age, because that's going to reduce the demand for loans, leading to a shift like we see here in the blue curve from A to B. Okay, so let me just mention one other feature that is, I think, interesting here. So I have just emphasized a few features that, in contrast to the representative agent model, can have an effect, and those were, demographics, persistent effect of debt deleveraging shock, and relative income of old versus young, and productivity. There is and I'm just going to briefly touch upon this because we don't really go into the details in the quantitative model. I think it's an issue for a separate paper that I haven't written yet, or anybody else as far as I know, which is that another pretty natural story for why we have seen a secular decline in real interest rate is the fact that we seem to have been observing an increase in income inequality across countries over the last, certainly in the U.S. over the last 30 years or so. So why would that matter? Well, in principle, it would not need to matter. But if it is the case that those that are getting higher share of the income for whatever reason are saving more, this could exaggerate this saving investment imbalance, or in other words, may require even further reduction in the real interest rate to clear the market. So in the paper, we just have one particular example of this mechanisms. Not particularly. You can do it, I think, in a lot of different ways. But we just gave one example where we just assume that there are two types of people: high income, low income, and then we assume that the low income are constrained not only when they're young but also when they're middle-aged, and then we redistribute more income from the poor to the rich, and that just creates more savings of those unconstrained high income middle-aged, and that's going to then an increase in inequality is naturally going to lead to a decline in the natural rate of interest. So that's another feature that I think is a pretty natural candidate for the secular decline in interest rate we have seen in the last few decades, even if in the quantitative model we're not going to try to calibrate our model to that particular feature. There's a sense in which there's an embarrassment of riches when we get to the quantitative model, in the sense that it's going to be quite easy to get permanently negative rates that one doesn't even need with relatively plausible parameter values. So, we didn't even have to include things like income inequality to get there. It was enough just to have slowdown in productivity and a few other things, and demographics, as I'm going to show you in a minute. Okay, so where are we? So we have basically shown you now, as promised, a very simple endowment economy, whereby it becomes, where we move away from a representative agent to a simple OLG setting, making the point that, well, there's no reason to expect why the steady state interest rate needs to be positive. It can be permanently negative. And there are slow-moving factors that affect that steady-state interest rate. And those include population dynamics, debt deleveraging, productivity, income inequality, and actually once you extend the model to include capital, the relative price of investment would be another candidate. But I guess the big picture point is just, unlike I'm sure is the case with many of you who are listening, since you're in this, most of you in central banks, when I was working at the New York Fed, I mean, our guesstimate of the long run interest rate was typically just the inverse of the discount factor of a representative household. Here, that sort of goes out of the window, and one needs a more careful analysis, and it can easily be moving across time and go into negative or positive territory. Okay, now, so what's the implication of the fact that you can have potentially permanently negative natural rate of interest, or the real interest rate needs to be negative for full employment? So before sort of showing you the full implication, let me just ask you to do a little thought experiment with me. So let's determine prices here just by adding money into the model. That determines the price level that I denote here in the first equation, P by PT. So that first equation, is just the equation that prices one period nominal bond. Okay, this is a consumption Euler equation that prices one period risk-free nominal bond. And we think of typically the central bank as controlling that one period risk-free nominal rate by open market operation in money supply. So once we introduce money in this economy, we're going to get this additional restriction implied by this consumption Euler equation for one period risk-free bond, and we're thinking of the central bank as setting the nominal interest rate here with open market operation in bond, except we take account of the fact that the nominal interest rate cannot go below zero. Why? Because you're not going to want to give me you're not going to lend me $1 unless I give you at least $1 back, abstracting from storage costs and such issues. So there's at least a bound to how far the nominal interest rate can go, given the role of money as a store of value. So what I want just to point out to you is a simple observation, and it follows just directly from this arbitrage equation here, the consumption Euler equation of the middle age on one period risk-free nominal bond. This is a bond denominated in dollars. And the implication of this equation is that given that there is a bound on the nominal interest rate, then in steady state, it better be the case that the inflation rate is above the negative of that, or above 1 over 1 plus R. For example, imagine the real interest rate, quote, has to be, the equilibrium real interest rate is minus 5%, forever. That's the steady state in our model. Well, the lowest the nominal interest rate can go is 0. So that means that inflation, denoted here pi, has to be greater than 5%. Right? There's no equilibrium consistent with, steady inflation below that level. Now, so what does that mean? That seems like, okay, you just introduced money and shown me that no equilibrium exists once the below 5% inflation, if the natural rate of interest is, below 5%. That seems, is there anything interesting about that? Well, I think this sort of non-existence of equilibrium shows up differently once you take into account that, well, the central banks can, in fact, force inflation to be below, for example, suppose that this, let's call this the natural bound of inflation is 5%. Suppose the euro need minus 5% real interest rate, meaning 5% higher inflation forever. There's every reason to expect the ECB could, in principle, prevent inflation from being that high. Now, that would not be a wise thing to do if this represented reality, but certainly an equilibrium, it's not hard to imagine an equilibrium existing in that world. Why? Because as long as you're willing to assume that prices or wages are not adjusting flexibly, well, then this refusal of the central bank to accommodate high enough inflation, to accommodate negative real interest rate, is going to show up in a persistent output slump. Okay? And that's what we're going to go into now. We're going to see how the fact that you have permanently negative natural rate of interest and a central bank that refuses to accommodate it with higher inflation, how this then spills over into a contraction. And by a contraction, I mean output is below where it could be if all factors of production were being fully employed. In the simplest case, that's going to be labor. In the more complicated case, that's going to include capital as well. We can imagine other factors of production in more complete models, of course. Okay, so let's then ask the question. So we have gone through the endowment economy and shown that you need to have that you need to have positive inflation. For if the interest rate is permanently negative, let's see how this may spill into a demand slump if the central bank does not accommodate high enough inflation. So here I just show you a curve. Okay, I'm going to show you some equation in a second. Let me just talk about them for 1 second before I get into the details, because I think the fundamentals of what's going on here is really, you can see from something that looks like an undergraduate textbook supply curve, aggregate supply curve. So what is it showing? It's showing, so this is different from, I suppose, what you see in textbook, undergraduate textbook, in that this describes a steady state. So what you see here is that in steady state, as long as inflation is above, gross inflation above 1, so above 0, you have just a vertical line. Okay, so if inflation in the 70s in the US was running at 10%, there would have been no effect on output. And I think there's a consensus in the economic profession that with high enough inflation, and expectation adjusting, then there's going to be no effect on aggregate supply. I guess what I want to point out, however, is that even if such a consensus exists in the profession based upon experiences in Latin America of large inflation that led to not good economic outcomes, or inflation in the 70s in the US, the stagflation, even if there's a consensus that there's some sort of neutrality that applies there, similar consensus does not really exist when you talk about deflation, right? There's not really a consensus that inflation below target is going to be neutral in the long run. In particular, if you look at, the data on the Great Depression, the data from Japan over the last 20 years, it looks like when inflation is below, when there's deflationary pressures, well, output seems to be going down as well. I mean, the origin of the Phillips curve really is when Phillips looks back in the 1950s, back on the data from the Great Depression, and there you see very strong trade-offs, which a large part of that is actually at very low inflation, when there's actual deflation in the economy. So our model is going to have this feature. It's going to have this permanent trade-off, and that is going to match this. So this trade-off, I think, is a realistic description of environment like we saw in the Great Depression or the Great Recession. But it still at the same time captures periods like the 70s when you have high inflation yielding no benefits. So how are we going to get there? I'm going to take the path of resistance, so to speak. So I'm going to endogenize production here simply by having competitive firms that have this production function where they hire labor with diminishing return given by alpha, that is less than 1. And labor is the only factor of production. Okay, firms are going to be perfectly competitive. I'm then going to, rather than dropping an output endowment onto the head of the household like we did in the endowment economy, we're going to give them time. We're going to give them a labor endowment that they can then rent out to these firms. And we're going to assume now, for simplicity, that only the middle generation get time it can allocate to work. Okay. And the key thing is going to be that we're going to allow for the possibility that not all of this labor endowment is employed. Why? Because there's going to be the possibility that wages are set above the market clearing level. Okay? So let me just note, so because this, of course, is an assumption that may cause some people to feel uneasy because, we have been, this has an old Keynesian feel to it. We have been looking much more forward-looking price-setting schemes in more recent work, and myself included in the last 30 years. Let me just point out what's really important here is just that there is a trade-off between inflation and output at inflation below zero. And you can actually get the same in a large class of models, including like the standard Calvo model. But I'm just doing this here for simplicity. So under full employment, the firms are just going to hire labor, so the marginal product of labor is going to be equal to the real wage rate. That's the second equation here. And then the middle generation supplies a constant level of labor L bar, and that's going to imply a market clearing real wage. And the full employment output is just an L bar in the power of alpha. Okay? But now we're going to move to a world in which perhaps not all of this labor endowment is employed by the firms. So how do we do that? Well, the most simple way to doing that is really, sort of the device Keynes really used, which was to say, well, let's imagine that for whatever reason, even if firms are behaving in a competitive manner, for whatever reason, the wages are just not adjusting appropriately. There's some wage norm that just refuses to adjust. So what we have here is a partial wage adjustment according to something I called wage WT tilde, which is a wage norm. So the oldest example being given by Keynes and others, that people would never want to work for a salary that is below what they got last year. Okay? And there is a literature, of course, on documenting the existence of such asymmetric rigidity in wages that I'm not going to attempt to survey here, but we survey to some extent in the paper. We have a generalization of that idea by saying that the wage norm, WT tilde, if gamma is equal to 1, the wage norm would be, you would never accept a wage below what it was last year. But we allow for instead that wage norm to be given by a weighted average of the nominal wages from last period, and then what the nominal wage would be if the market would clear. The idea being, if there's a large degree of unemployment, well, then maybe you would be willing to accept some wage cuts. Okay. Now, the key thing, though, to notice here is that this wage norm is asymmetric, so that even if you don't want to accept a cut in your nominal wage, you're always happy to get higher salaries, right? Hence, there's the max operator here in WT. It's going to be the max of the wage norm, or what the wage would be under flexible wages. And that is going to give us the shape of this aggregate supply curve that I showed you before. Okay. So if the real wage exceeds market level, employment is basically going to be rationed here. Okay. So the real wage is going to be too high. So the firms are not going to fully, remember the first order condition of the firm was just given here, right? So they're just not going to hire all the labor needed to clear the market to hit that wage rate. And the wage rate is going to be given by the norm, and then may or may not be consistent with full employment. Okay. So for positive steady state inflation, well, then this economy, then basically the flexible wage that we saw here is going to be operative, and it's going to look like a fully flexible price economy, and output is going to be given by the labor endowment. Things get just more interesting once you have inflation below the zero, because then you're going to get this sort of trade-off between inflation and output. And let me just make a quick observation that there's nothing special here about zero inflation. In the paper we generalize. You can also imagine that the wage norm is given by some fixed increase in the wages per year, that everybody expect 2% wage increase per year, and then the kink is going to happen at a different level than zero. So in any case, what this is going to show you, and that's just what this shows you here, these two equations, is an upward sloping relationship between inflation and output, until you reach full employment when you get a vertical line. And what's the intuition? The intuition is just if the real wage rate is too high, well, then the firms are not gonna hire. Then they're gonna hire fewer people because the wage rate, the marginal product of labor at full employment would not be as high as the wage given by the wage norm here. Okay, so this is then how the aggregate supply relationship looks like in steady state, and that's the first piece of the puzzle. The second piece of the puzzle is now the demand side. So what's the demand side? The demand side is just the consumption of the young, middle-aged, and the old. And now that we are allowing for wages potentially not adjusting to market clearing level, we have a demand-determined economy, or one in which is determined by where demand intersects supply. So the monetary policy rule here is given by the first equation here. So it's just like a Taylor rule. So you're going to increase your nominal interest rate if inflation is above the inflation target of the central bank in proportion to this phi pi parameter. So then we can just substitute this policy rule into aggregate demand that is given by the consumption of the young plus the consumption of the middle-aged and the consumption of the old. And that equation is above the zero lower bound is given right there in the middle. And you see that it bears stark similarities to the expression for the real interest rate I showed you before. That's the right-hand side, and then the left-hand side is just basically the Fisher equation, that the real interest rate is equal to the nominal interest rate adjusted for inflation. Okay, so that's a positive interest rate, but then if the implied interest rate given by this policy rule is such that the central bank needs to set negative interest rate, well, the zero bound becomes binding. Okay, and then the third equation here applies. So let's see how this thing looks like just graphically. Okay, so I've explained for you the aggregate supply curve that is vertical once you have employed the full labor endowment, but once inflation is below steady state inflation, then real wages are too high. So the firms are not hiring the entire labor endowment. The aggregate demand is going to be upward sloping when interest rates are positive, because the central bank is going to increase the nominal interest rate more than 1-to-1 to stimulate demand. But at some point, you're going to hit the zero bound, and that's the kink, where you cannot cut the nominal interest rate any further. So at that point, in fact, the aggregate demand is going to be upward sloping. So why is aggregate demand upward sloping here? Well, that's because now you're holding the interest rate fixed, and aggregate demand here depends on the real interest rate, the difference between the nominal and expected inflation. So as you increase inflation and don't change the nominal interest rate, you're reducing the real interest rate and thereby stimulating demand. And you can think of this is working here actually through the both through the debt channel, the fact that the real interest rate allows the young to take on more debt, but you can also think of this as working more generally just through the consumption Euler equation of the middle age, that they want to consume more now that they face lower real interest rate, like in standard models. So that describes this upward sloping relationship on the aggregate demand side between inflation and output, that then switches once you reach the target inflation, because at that point any increase in inflation is going to be offset more than 1-to-1 by interest rate increases. So what to take out of this here? Well, a normal equilibrium here would be given by the intersection of AD1 and the aggregate supply curve at positive inflation. Okay, so this is a well-behaved economy that appeared to be functioning at full potential, and monetary policy is neutral here in the long run. But what happens then if there's a shock to spending that require the real interest rate to be negative? Okay, think back to an endowment economy. Think about any of the forces that implied that the real interest rate had to be negative. Well, in that case, you have a backward shift in the aggregate demand curve, and if the inflation target of the central bank is not high enough, the only intersection between the two lines is going to be in the deflationary steady state at the in the secular stagnation. So the secular stagnation here is then a world in which the central bank would like the real interest rate to be, let's take for example minus 5%, is unwilling to allow for 5% inflation. So the only solution then that you can see is one in which there's going to be persistent deflation, or more generally inflation below target, and persistent underemployment of workers. Okay? So what we have then seen so far, I showed you a most basic model to get permanently negative rates, and then how that could translate into permanent slump. And basically this slump will last as long as the zero lower bound is binding, and one sort of distressing aspect of this equilibrium is that it's not like things become better as wages become more flexible, because that just makes the deflation even worse, raising inflation by even more, and making the equilibrium even worse. The way to see that is that more flexible wages just makes the aggregate supply curve, where it's downward sloping vertical, which leads to actually a worse outcome. So it's hard to see a natural mechanism through which the economy finds full employment here. I suppose one thing you could imagine is that people just stop participating in the labor force, so that would tend to shift the aggregate supply curve back. But that's perhaps not the kind of adjustment that you would like to see in an economy, that the deflationary pressure subside just because people exit the workforce. And I mean, there was some of that, I think, during the Great Recession. Okay, so I've shown you how you can get a long slump, and it's secular stagnation equilibrium that always exists here as long as there's some rigidity, and it has features that are desirable for models that have been absent in some previous attempts to model permanent stagnation at zero interest rate, in the sense that the steady state is unique and determinate, meaning that we can do comparative statics, meaning that you move a little bit away from it, and there's only one equilibrium just around the one that I just showed you, as opposed to indeterminacy, as we see in some other work that has tried to model persistent deflations. Okay, so let's then move on to thinking about, before moving on to thinking about implication, I just want to show you, and this picture is a bit grainy on my screen, and I'm guessing it's pretty grainy on your screen then as well, but nonetheless, let me tell you what it attempts to show. It attempts to show for the United States, Japan, and the Eurozone the evolution in output per capita, interest rate, and an inflation rate. And the basic point the picture is trying to make, and I don't want to present this as some sort of overwhelming victory of the model. It's just saying, well, the model can account for the three big movements we saw in the data: a permanent decline in output from trend in the United States, Japan, and the Eurozone, a permanent, persistent decline in the nominal interest rate, and inflation rate that was not negative but below its steady state. Okay, so that's what we see here for the U.S. The first columns. For Japan, we actually added a mechanism that allows for hysteresis, so we see that the potential of the Japanese economy is also slowing down, and there we see actual deflation. And so the basic point here is just to say, so we have parameterized this very simple model and put in parameters we think are reasonable, done transition dynamics, and the basic point is, okay, and this is in contrast to the standard New Keynesian model of the sort that I've worked with in the past. You cannot really have a persistent slump of this form that is permanent. The model actually blows up. A point that has been emphasized by many authors. If the shock is too persistent, there's no there's no equilibrium. But here you get a well-defined equilibria that, arbitrary long slump that can last for however long, however long you might think the shock, however long what's driving it is not abating. Which comes down to then, okay, so why do we think the interest rate were declining in 2008, which gets sort of to the quantitative question that I will get to in a second. But before getting there, I'm going to briefly comment upon monetary and fiscal policy choices. And I say briefly because I also want to leave a little bit of time for the quantitative model. So what I want to just highlight in the monetary and fiscal policy part is the difference that we get from this framework relative to standard New Keynesian frameworks. There I have in mind, to cite myself, papers like Eggertsson Woodford 2003 or my work with Krugman from 2012. Okay, I want to emphasize what are the differences that this gives us relative to the standard framework. So the first point is that, well, to the extent that you think this is a permanent state of affair, forward guidance is not going to do much for you. What do I mean by forward guidance? Well, I suppose if you listen, you probably know what I mean. Forward guidance is just, the practice of central bank, when faced by the zero bound, to commit to do something with interest rate in the future when people believe that interest rate would no longer be binding. Well, if people are expecting them to be binding forever, well, then there's very little you can do along that dimension. So extended commitment to nominal rates may not be as effective in this world as in some previous work. The other feature here is that, now this, and that relates to the dynamics I showed you, is that this model can characterize sort of gradual, long-lasting slump, and it's not as extremely forward-looking as the standard IS equation in the New Keynesian literature, something that John Cochrane has criticized it heavily for, and Steinson and Nakamura and McKee call the forward guidance puzzle. So this model does not suffer from that. Now, was to come to monetary policy, there are essentially two key differences between this framework and existing frameworks. The first is that it is true that a sufficiently high inflation target is going to get you out of trouble. But it comes with two caveats. Okay? The first caveat is that it better be high enough. That's what Krugman referred to as the timidity trap. It better be high enough, otherwise nothing will happen. Second, even if you announce an inflation target, you haven't really excluded the possibility of a secular stagnation equilibria. So under the hood of the New Keynesian model was always this assumption that the shocks are temporary, so at some future date the interest rate is positive. And you could sort of hang your hat on that future anchor, and at that point, if you promise high enough inflation, at that point you can work yourself backwards and get yourself out of trouble during the CLB episode. If you don't have any fixed point like that, well then you may not be able to pick between the two equilibria, the good one and the bad one. So both points are illustrated here in this figure. So what does this figure show us? Again, we have here the deflationary steady state as before, and it's the unique steady state for AD1. If you increase the inflation target, the effect that has is just to change that kink point in the aggregate demand curve. You're just accommodating higher inflation. And the first point is AD2. Suppose the natural rate of interest is -5. If the central bank say, I'm willing to allow for 3% inflation, well, that's not going to do anything because there's no cutoff there between supply and demand. At 3% inflation, the natural rate, the real interest rate can, best be -3%. And if you need -5%, that's not going to do the trick. Here you see then the green line is something, okay, let's suppose it's -5% the natural rate of interest and I announce a 10% inflation target. Well, then you get a second intersection. But again, and that's the second, the point here is that you just get a second intersection. You have not really excluded the bad deflationary steady state. Okay, so you have multiplicity of equilibria. So that might give some pause of concern. Let me just add a third caveat, which is not in the paper, but one that I think that will receive increased scrutiny going forward if we find ourselves in these kind of situations. If you accommodate this shock with, let's say, it's minus 5%, the net rate of interest with, say, 10% inflation, you get minus 5% real interest rate, and you're out of trouble. I guess one question that arises there, is there something in that environment that may cause other kind of troubles? And one obvious candidate is that when the real interest rates are permanently negative, that's a world in which you might see asset price bubble that might be its own source of instability. Let me just leave it at that because we don't have anything about it in the paper, but I think that's certainly one sort of additional caveat one could think about here if the solution is a permanently negative real interest rate. Okay, fiscal policy. So I'm going to jump over that and just tell you that now debt is directly, so Ricardian equivalence failing here, so that directly has an effect on the demand for loans. I mean, the government is stepping in there, and its effect is going to depend on people's expectations about the taxes on the middle age and the taxes of the old. In principle, I mean, increasing debt won't do anything. Imagine giving a lot of money to the middle age, and then they expect to be taxed for it when they're old. Well, then Ricardian equivalence would hold, and nothing would happen. So the expectations about how the debt increase is financed is critical here. I don't think it's too unreasonable to come up with some assumption about fiscal policy where the increase in debt is not offset by increases in people's expectations about future taxation. And the interesting aspect of that is that in that case, and this shows you here the effect of fiscal policy, and this is and I just want to contrast this to monetary policy. Remember, monetary policy just allowed for a second intersection of the two curves. What fiscal policy is doing here is something different. It's actually changing the underlying natural rate of interest. It's making it going from negative to becoming positive. And you can think of that, and that can happen in a variety of ways, either by directly increasing debt or government spending with different financing schemes. But the key sort of takeaway, and the devil is in the details a little bit there. The key takeaway, though, is this notion that you're shifting the entire aggregate demand schedule. So you're eliminating and increasing the natural rate of interest, thereby eliminating the secular stagnation steady state. So I want to use the last minutes I have. So I know I went relatively quickly through the fiscal policy, but this was somewhat by design because I wanted to talk to you a little bit about a quantitative model. I suppose an obvious objection you may have at this point or concern is, well, you have shown me Samuelson's 1956 OLG model with some tweaks with zero bound and normal wage rigidities, and you showed that in that world you can have permanently negative real interest rates and you can have a slump, provided there are some trade-offs between inflation and output, a slump that may last forever. But how realistic is that? Is it really plausible to believe that the real interest rate in the world are going to be, need to be permanently negative going forward? So it's hard to base an answer to a question like that on data as short as it is. So I suspect that the best we can do is just to try to write down a model. So let me, before I go to that, I just got a question here. Is it reasonable to consider a case when the debt limit is changed by policy, and would that have an effect on equilibrium? So that's a good question, and one that we talk about some. And so a change in the debt limit here is in fact one that increases aggregate demand, and it is one that might improve things. And I think it's interesting. So now the question is, would that be a good policy? I suppose that depends. I think one interesting sort of observation is that after the crisis, a lot of, because people thought the crisis was triggered by too much debt, a lot of the, in other words, that was the reduction in D from D high to D low. That was the Krugman, that model had the Krugman. Then in response, a lot of governments tried to make sure there would not be any further increase in debt. But you can kind of see here that, that's actually exactly opposite to what you want. I mean, in fact, you would like lending standards to go back to where they were. But, of course, people were doing that for good reason, because they thought that that was a trigger of perhaps future crises. But yeah, I mean, it is true here, and strictly speaking, the model, if you just increase that D, you actually achieve a better outcome. But, since we haven't modeled in detail the D, I'm a little reluctant to go too far in that direction. But the overall message, though, is, restricting the supply, the demand for credit, or the supply of credit, is not a good thing once you're in a situation like this. Okay, so let's talk about the quantitative model here. Let's see if I can get this to fit the slide. Yes. Okay, so the main question I want to try to contemplate here with you is whether any of this that I have just said has any quantitative resonance, or is it reasonable? Can we build a quantitative model that captures sort of key features of the US data and maintain the conclusion we have just reached? And what would such a model say about what has been driving the real interest rate, which we have seen have been declining over the last 35 years? So the approach we're going to take here is that we are going to build a medium scale OLG model. So I just showed you one with 3 generations. Now I'm going to have 54 generations. People enter their working force at 25 and they die at 81. But there's going to be a probability of dying while they are active in the labor force. Furthermore, we are going to include here capital, and we're also going to include markups and other bells and whistles, which allow us to sort of quantitatively match some of the things we observe in the data. So this here is now the world that I'm proposing to you. Instead of people living for 3 periods and living in log utility function, they have sort of generic CES utility function, and they live from the J takes a value from 0 to big J. Okay? S superscript J, here is the survival probability, and the probability of being alive in period, of surviving to the next period. We assume for simplicity that people die with certainty at age 81, and that's this S superscript J, whereby you're gonna leave some bequest to your descendants. The budget constraint here is different from what it was before in several respects. First, if we start here on the left-hand side, I'm going to allow for, there's going to be a change in the relative price of capital, meaning that we're going to allow for the possibility that it's become cheaper to produce capital today than it was yesterday. And this is based upon the observation that the relative price of capital appears to have been falling in the data, which is an independent force that we wanted to explore. We see here that the wage we give here, this HCJ, is basically the human capital profile of the worker. So we are going to calibrate that to US data. So we're going to, people take account that they have a hump-shaped income profile. So that's going to give them incentive to take on some debt when they're young, to buy a house and for their student loans that they pay off in middle age and save for retirement. There's going to be some profit here given by pi JT, for reason I'm going to tell you in a minute, and then there's going to be return on capital and these assets. Now, we're going to use a trick here common in this literature that people are going to insure themselves against, they're basically going to be buying into an annuity. So they're going to insure themselves against death in the sense that, if somebody dies, his assets get distributed to the remaining people in his cohort. And similarly, the bequest gets distributed to all people at the age of 56 in the model. So we're going to have a debt limit as before, and now we're going to have a total labor supply that is the sum of the labor supply of each of the age cohort given by HCJ. That's the last equation on the slide. Okay? So that's the environment on the household side. On the firm side, the difference is going to be that two differences. We are going to allow for the possibility that, so there's going to be an intermediate good firm that has this CES production function. So this is just a generalization of the Cobb-Douglas function. Okay, so that's going to be the intermediate good firms. But we're also going to allow for a final good that uses the intermediate good as an input and extracts some monopolistic profits. So the intermediate good producer produces a gray box, gives it to the final producer, and he can paint it blue or red and differentiate it from everybody else, and that allows him to extract some markup. Okay, so why do we do that? Because one of the things we have seen, and is sort of required to manage the data, is a secular increase in the profit share or decline in the labor share in the data. Or another way of saying it too is that while marginal returns as measured by interest rate have been declining, average return measured in the data have actually been pretty stable. And this, now, we actually have with other co-authors a paper that is devoted specifically on that point, but that sort of just gives you a little bit of background on why these assumptions are made here. Government is just going to be issuing debt and doing some spending and some taxes. We start for steady state, and then we also analyze transition dynamics, going from 1970 to today, taking certain variables as given. Okay, so what is it that we wish to do with this quantitative model? This is a bit of a mess, this model. It has 56 generations, so it's not totally trivial to solve computationally, although it's not, it's certainly not something that people haven't done before in various applications. So what we're going to do with this model, two thought experiments. We're going to ask inside of this model, okay, I showed you a framework here that I think I can discipline by the data, and I can ask the question, which I think a lot of people were skeptical when I first showed them the 3-period OLT model: is it reasonable to believe that the natural rate of interest can be permanently negative? In other words, people had this intuition that, oh, well, if it's permanently negative, something needs to be off, like, maybe investment output ratio explodes, maybe, there was or you need to assume something totally unrealistic about demographics or productivity and so on. And I guess the way to think about the first thought experiment is just sort of a proof of concept. It is that, well, actually with relatively standard parameter values, we can easily generate permanently negative natural rate of interest. And I think the way to interpret that then is that within the context of sort of modern theory or modern class of models, and I don't know if one should be surprised by that or not, I don't think it was totally obvious ex ante, there's no particular reason to expect the steady state interest rate to be positive. It can easily be negative under plausible specification for parameters we like to stick into our models. So That's going to be the first sort of proof of concept question. The second one is, well, inside a model like that, which, this is going to be a flex price model akin to the endowment model I showed you before, can a big model of this kind generate a permanent recession? And the answer then, again, is sort of a proof of concept notion, and the answer there is yes. Secondly, we're going to do sort of an accounting exercise, which I think is interesting and gives us some sort of check on that the calibration makes sense. So we're essentially going to calibrate the model to account for real interest rate of minus something like minus 1.5, which is what the real rate was in the US in 2015. We're going to calibrate it based on that. And there's going to be a bunch of variables such as mortality, birth rate, productivity, and so on that are going to be given from the data. One thing we can do is, okay, taking 2015 as an initial point, let's replace the 2015 values with those we observed in 2017. What does the model predict? Well, lo and behold, the model accounts for the drop in interest rate from 1970 to present day. So it's in some sense a check on that our calibration is reasonable and can in fact account for the drop in interest rate. Perhaps even more interestingly, we can then decompose what are the sources of the drop bar. And we can also ask counterfactual, okay, what do we need to do in order to get the interest rate back up? And just to preview, what we're going to find here is that there are three key drivers of the drop in the real interest rate, according to this model. It's going to be the slowdown in productivity, the drop in fertility rate, and decrease in mortality rate. Okay. So I'm going to go briefly through. So here, the first out of the two thought experiment, I'm going to set the natural rate of interest equal to minus 1.5 approximately. And have no output gap. So I'm going to study the flexible price version of the model. And of course you could ask then why was inflation running below 2? You might have thought that was because there was some output gap. So the natural rate of interest was in fact smaller. So then the second exercise is going to take sort of the other extreme of the spectrum and say, oh, let's assume that the output gap is given by deviation from trend, which some people in 2015 estimate to be as high as 50%, and see can the model account for such a huge output gap, and what's the implied natural rate of interest? And the answer there is 2.20. The answer is yes, it can account for it, and the natural rate of interest is in minus 2.25, and you can account for the low inflation and some of the observables to 2015. Okay, so let's just go through these thought experiments. So the calibration consists of three sources: direct data, parameters taken directly from the literature, and then parameters we match targets with. Okay, and the direct data, and I'm afraid I'm running out of time, so I'm going to go relatively quickly here. The direct data is we get the mortality. This is, remember, we are trying to look at 2015. Mortality profile, fertility profile, income profile, productivity growth, government spending, and public debt. We all pick this from various sources. We take this from the literature and experiment then with different values. We, as usual, blame somebody for the values we choose, but then, allow for different values in an appendix and do a sensitivity with all parameters. And then finally, we pick the remaining parameters, beta, d, mu, theta, and alpha, to pick these targets here in the data. The natural rate of interest, the investment output ratio, consumer to debt ratio, labor share, and bequest to output. And remember, the idea here was to ask the question, can we account for this low interest rate that is here a steady state phenomena with reasonable parameters? And I've shown you a bunch of parameters that I took directly from the data, then some from the literature, and then these past 5 are taken to match these moments. And here we wind up with values that are actually, picked so as to match these moments exactly. And the values needed to match these moments exactly are in fact in the range we report as people have found in the literature. that is sort of gives us the proof of concept idea that yes, for reasonable parameters we can indeed have permanently negative rates for the parameter configurations close to what one might think characterize the US data today. Okay, so the second experiment is just showing that you can also, with this parameter configuration, but now allowing for nominal rigidities, account for a substantial output gap in the big model in 2015 with inflation below its steady state value and an output gap of 15%. Okay, so that was the first two part of the quantitative section, which was basically sort of a proof of concept. Are permanently negative real interest rate reasonable? And by that I mean, can we pick parameters that don't look wildly out of sync with the data and get what we think makes sense? And the answer is yes. And can this model generate a permanent output gap? The answer is yes. The second then was accounting for the drop in the real interest rate, feeding into the model the stuff we took from the data, the 1970s parameter values. Okay, and that's what is being done here. And what this here is showing you is that we just plug in the 1970 values for mortality rate, toward total fertility, and productivity growth, and government debt, and the relative price of investment, and then this shows you that this does can in fact account for both drop in investment to output ratio. It even over explains it, and that was one of the things that people were skeptical of that we could do. And the natural rate of interest that accounts for the drop in that as well. The model has a 2.555 and the US data is about 262. And if we decompose this just as a decomposition of the various sources, and I guess the point here is just that what is driving this mostly is the fall in productivity growth and the mortality and the fertility rates. That's sort of the big ticket items that, at least in this model, are driving it. So what should we take out of that? I suppose what I would take out of that is that to the degree that, in fact, the total fertility, the decline in fertility and increase in life expectancy, decrease in mortality. I think I may have been using the inverse some of the talk. People's life expectancy has been increasing. To the extent those things are driving it, you might be somewhat skeptical about that those things reverse themselves. Absence of plague or sudden boom in fertility. And you can see here to reach, this shows you how do you get back to 1%, what is the counterfactual value you need to get there. And you see you need 3.258 for fertility, you need government debt to go over 200% of GDP, you need productivity to be about 2.45, and relative, and the last one is perhaps less interesting. The bottom line, though, is that it's not there are no obvious solutions that offer themselves here, and perhaps the biggest thing is the productivity. If the productivity reverses itself, we might have avoid this issue. Okay, so let me conclude. So does low interest rate represent a new normal? Possibly. I think this paper raises that possibility, and it tries to provide a framework to analyze what ingredients are needed for that possibility to bear out in the future. If it does, we're going to see the zero bound being binding again in future cycles. I said I was going to talk about open economy dimensions, and I guess I ran out of time. But here is a side to the paper that I was discussing, because that was indeed the direction we took after having written this paper. Was what's the implication here for open economies? And there, the key point is that these saving investment imbalances transmit themselves through current accounts in an open economy. And then a big saving investment imbalance in Japan can transmit itself into lower interest rate in the US, and they can't be so low that they hit the zero low bound, in which case, even if low interest rates are good, being at zero and not able to cut rates in response to recession, not so good. So there you might have a problem. So thank you. Let me end it at that. I think I've reached run down the clock to 1:30. So thank you very much for listening.
Very much, Gauri. I don't know if someone has a question or a comment. Please feel free to write it down, or I'll be happy to open your microphone. So I have a question about perhaps the possibility of playing with this model or one of the models in a different setting. Say people who are developing their papers and perhaps trying to make their own calculations for their own economy. How feasible it is like to replicate the say this either this paper or the one that you have with Larry Summers. That perhaps.
I think I I think we have the codes posted. They're not that difficult to replicate, in my view, because these models really become computationally heavy once you have uh, idiosyncratic uncertainty. But here you don't, so you just have a large system of equations, but not one that is, I think, too difficult to solve computationally. Um, this is true for the paper I gave you, but it's even more true for the paper with Summers, where we had either actually a simpler model than we have here. But I think, I mean, in general, I view what we did with the OLG section more sort of as a proof of concept. I think we are just seeing the beginning of more usage of OLG models for business cycle analyses. Because before they had mostly been used just for thinking about pension plans or social security. But I think, in fact, one of the things one could take out of this is that those life cycle dimensions can also be important to think about, short-run fluctuation and, long-run natural rate of interest. So I expect, and that's a long way of saying that I think the cost of computing these things is going to get cheaper and cheaper as people start using these models more and more.
Any other question or comments?
Mm-hmm. Yeah, so we have posted those online, I believe. And if anybody has any questions about them, feel free to just drop me a line.
So I guess we we can finish here, Gabriel. We really thank you for this very interesting presentation. I'll be in touch to share you the recording. Thank you. Bye.